All right, we're back. Part 2 here of finishing up the notes for calculus that I lost the video for earlier. So, where we left off was talking about the different rules, right? We had just mentioned that the derivative of a constant is 0. Okay, so any derivative of a number is just 0. Because again, the graph of any number is just a horizontal line. The slope of that function then would have to be 0. Okay. For the power rule, right, we also determined that the slope or the derivative of a function x raised to the n is the derivative of that is simply n times the x again to the now n minus 1 power. So again, back to our examples here, pi squared, its derivative, you might be tempted to bring the 2 out front and do 2 times pi to the 1, but pi squared is just a constant. It's like 3 or 10, okay? Its derivative is 0. If you were to graph pi squared, it's a horizontal line that goes, that has a slope of 0, so the derivative would be 0. Here for g of t, okay, cube roots, we had something we need to be able to rewrite. So we rewrite the cube root of t as t to the 1/3. And then we can take its derivative. Well, again, the 1/3 comes down out front. Lower the power by 1. So 1/3 minus 1 is negative 2/3. And so there's our answer. Or rewritten with positive exponent, it'd be 1/3 times 2 to the 2 times t to the 2/3. For letter C, okay, we want to rewrite this as well. We do not know how to take the derivative of 1 over x squared as it's written, right? We need to rewrite it into the format that we know, which is x to the negative 2. We can take the derivative of that. X to the negative 2, its derivative, again, the negative 2 goes out front, lower the power by 1 to negative 3, and there's your derivative. All right. And so then we use that here in an application, right? We want to be able to write the equation of the tangent line to the graph of y equals x squared when x is equal to negative 2. Okay? So to write the equation of a tangent line, you need to come up with the slope of the function at that point of tangency and also a point that's on that function. How do you find the slope of a function? Take the derivative. Derivative of x squared is 2x. Plug in the negative 2 to get your slope of negative 4 at that specific point. Then you're going to plug negative 2 into the original function here to get the coordinate of the point of tangency, so negative 2, 4. And then I use point slope form to write the equation of the line. All right. Now, example 5 here, it asks us to use the definition of a derivative to find the derivative of f of x equals 3x squared. So back to our limit definition there. If we do that, we see that we end up with 6 times x to the 1, okay? Which, if you look here, you're maybe not surprised by that, right? Because we see that, okay, what is this? It's just using the power rule again. The 2 would come down out front and multiply with a 3, and then the power of 2 would lower by 1 to get to 6x to the 1 there, okay? And that's true in general, okay, for the power rule here. The derivative of the constant, the derivative of a number times f of x is equal to c times f prime of x. Okay, so you can just kind of pull that constant out and then take the derivative of the function and then multiply the constant back in. Okay, so as some examples here, and this is as far as I got with my classes, the derivative of 4/5 t cubed, I suggest that we rewrite that as 4/5 times t to the 3rd. Taking the derivative then, the 3 multiplies out front to the 4/5 to make 12/5 t to the 2nd. Here, for letter B, 1/2 times the cube root of x squared. We should rewrite this. The cube root of x squared is the same thing as x to the 2/3, but then bringing it out of the denominator makes it x to the negative 2/3. Take the derivative of this, negative 2/3 times 1/2 gives us negative 1/3, and then x, and then lower the power by 1 to the negative 5/3. All right. And then finally, letter C here, 3 pi over 2k. Again, our variable here is k, so we're going to take the derivative with respect to k. So I'm going to rewrite that again as k to the negative 1, and then 3 pi over 2 in front of it. That's a coefficient. Again, the negative 1, when we take the derivative, goes out front, so it becomes negative 3 pi over 2, k to the negative 2. Okay, that's as far as we got. We'll continue on and finish up 3.2 on Monday. We're going to look at some trigonometry and also the letter E as well, and taking its derivative. So yeah, be ready for that. Good times.